Okay, example 2. The members of the girls' club hiked to Lake Superior at 2 miles per hour. Mr. Ali gave them a ride back home at 12 miles per hour. Their entire trip took 7 hours. What was the girls' hiking time? How far was it to Lake Superior? So, the girls are somewhere. Let's just say the girls are right here. What are they doing? Where? Lake Superior. So, they're starting here, and Lake Superior is over here somewhere. And the girls are here, and they hike to Lake Superior. How far is it to Lake Superior?
We don't know.
We don't know. So the girls went some unknown distance hiking. That's how you draw the distance expressions here. D subscript H, H for hiking. Then what happened?
They drove home.
They drove back home, right? So now they're at Lake Superior. Mr. Ali's right there. He's waiting for them because he must be their leader of the pack. Anyway, he gave them a ride back home at 12 miles per hour. So he's here in the truck, they hop in the truck, and they drive back. And this is distance riding. Do we know that distance?
No.
So they went somewhere, they went back, they did a round trip. The distance going and the distance returning should be the same, right?
Mm-hmm.
There wasn't some earthquake as they got done hiking, looks like Superior, all of a sudden there's an earthquake and the earth separated and all of a sudden they're further away than they were or whatever. So the distance there, the distance back are equal. So the distance hiking is equal to the distance riding. That's another scenario where the distances might be equal. The characters in the problem make a round trip. Okay? The categories I chose to make were hiking and riding. And again, notice when I drew that picture, I didn't pay attention to time, I didn't pay attention to speed. All I care about is distance when I'm drawing that picture. They went somewhere, unknown distance, they went back the same distance, distances are equal. That's how we draw the picture. Once I've got that in control, once I have this figured out, how the distances relate, my next goal is to figure out what these are by first figuring out the rates and times. So, what is the rate hiking?
2 miles per hour.
2 miles per hour. They hiked at 2 miles per hour and 2 miles per hour. Put your units up in here. Once you know the unit of rate, it's very easy to know the time and distance. Miles per hour. So time is going to be in hours, distance is going to be in miles. The rate unit always contains the distance unit above the time unit. So miles, distance per hour, time. How fast did they ride back home?
12.
12 miles per hour.
It's not very fast.
Not very fast. I think it was under probably rough terrain. Maybe they're on a 7-seater bike, I don't know. There were 6 girls in the girls' club, by the way. I just made that up. And Mr. Allen, that makes 7. They were on a 7-seater bike, so that they can go 12 miles per hour. Doesn't say they were in a truck. Yeah, so yeah, they were right back on a 7-seater bike. All right. Now, the next thing is something that messes up people all over the place. I don't understand why. That's one of my faults as a teacher right now is I don't know how anybody can't get this. If you're one of the people who can't get it, if you can explain to me why you don't get it, maybe I can understand better how to teach it better. I don't know. But their entire trip took 7 hours. Does that say they hiked for 7 hours?
No.
No.
Does that say they rode for 7 hours?
No.
No. That says their hiking and driving time together is 7 hours, right?
Mm-hmm.
Do I know either time?
No.
No. All right. So with that in mind, I don't know either time. I need to make one of those times t. It doesn't matter which one you make t. Make one of them t. T is some amount of time, right?
Mm-hmm.
What's the biggest t could be? 7. What's the smallest it could be?
0.
0. Okay. 0 if they didn't hike at all. 7 if they hiked the whole time. Either way, it's obvious it's neither one of those answers, right? Because if they hiked for 7 hours, they didn't ride. If they hiked for 0 hours, they didn't hike. So they hiked part of the time, they walked part of, they rode back part of the time, right? T is some amount of time. What's left over from 7 hours?
The rest of the time?
The rest of the time, okay? So let's figure out this. Let's do numbers first. If this is 1, how big is that?
6.
6. If that's 2, how big is that?
That's 5.
If that's 3, how big is that? 4, right? I heard somebody say 4.
Yeah.
I heard Mitchell go, well, whatever he did. But anyway. Okay, what I want to ask is how are we getting these numbers off of those numbers?
By the first.
Subtracting what?
The first.
The first from?
Seven.
From 7, right? 7 minus 1 is 6. 7 minus 2 is 5. 7 minus 3 is 4. 7 minus 4 is 3, right?
Yep.
7 minus 5 is 2. 7 minus 6 is 1. 7 minus 7 is 0. 7 minus t is? 7 minus t, right? So whatever this first time is t. If I know the total time, the entire trip took 7 hours, the entire trip, whatever it took, minus what we've already used is what's left over. With numbers, it's very basic and obvious. With letters, it's not as obvious. But what you have to do is allow yourself that abstract thought. I don't know how big that is, but it's something. To get this, I have to take 7 minus that something. That's what's left over. If I use 1, 6 is left over. If I use 2, 5 is left over. If I use t, 7 minus t is left over. Okay, and again, to me, that's pretty basic stuff. Students in the past have had difficulty with that idea. I kind of explain it like that every time. I can't think of a better way to explain it. So, if that doesn't make sense, you let me know. You tell me what doesn't make sense about it. Maybe that'll help me teach better. I have yet to have a student take me up on that, so we'll see. Oh, the year I retire, that'll be the year the student. Oh, this, and all of a sudden I figure out how to do it. But anyway. Rate and time, rate and time. These 4 boxes were filled in from reading the problem. I knew exactly how fast they're going. I didn't know either time, but I was able to get the same variable represent both. Rate times time equals distance, so 2t is their hiking distance.
And 84 minus 12t?
84 minus 12t is their riding distance. And again, we've already established those distances are equal to each other. So the hiking distance 2t is equal to their riding distance of 84 minus 12t. If I move the 12t to the left, that becomes positive. So I get 14t is equal to 84. Divide by 14. 84 divided by 14 happens to equal 6. And notice t is in this column under the hours heading, right? This is 6 hours. So all I figured out right now is how long they hiked, right? They hiked for 6 hours. How long did they ride? 1 hour, right? So again, once you know an answer, it's really easy to find more answers. This is 6. 7 minus 6 is 1. What are they asking for?
Both.
Hiking time, which that's that, right? So that's t sub h, so we're good there. What else are they asking for?
T sub hours, or so how much time took to ride?
No, they didn't ask for that.
How far was it to Lake Superior?
How far was
1
it?
hour.
So rate is how fast. We know that. Time is how long. And distance is how far. So how far was it? So they're asking for the distance to Lake Superior. That's this, right? It's also this. Take your pick. I like that one better, don't you guys?
Yeah.
2 times 6 is 12 miles. So distance to Lake Superior is 12 miles. Also, once we know that's 6, what's 2 times 6?
12.
What's 12 times 1?
12.
Once you know the rates and times, just multiply to get distances. They're supposed to be equal to each other, right? 2 times 6 is 12. 12 times 1 is 12. Same distance traveled. Total amount of time traveled is 7 hours when they rode for 12 miles an hour and hiked to 2 miles an hour. The chart should all work well together if you get all the correct answers in there. But again, make sure you answer the questions they're asking for. Those are the 2 questions they asked. That's what I'm going to answer.